Okay. For the purpose of the recording, picking back up in lesson 4.3, example 2b. If you go, you have to go back to the previous page to see the directions, don't you? So the directions ask us to, given the following table of values, find the quadratic equation in standard form. You guys are rock stars. You know standard form now, right?
Yes.
Okay, standard form. Y equals ax squared plus bx plus c. That's old news, isn't it? We're getting very familiar with it. I would love to say that's memorized, but even if it's not memorized, you're familiar with it, okay? So, what do we know about these ordered pairs? This ordered pair of negative 1, 2 are what kind of values? They're x and y, right? So I'm going to write it here, negative 1, 2. And I'm going to remember that this is x and y. So if you recall from yesterday, we took those values and plugged them in, right? It says y equals. So for y, I'm going to put 2 equals. And then every place I see an x, it becomes negative 1. So a times x squared is going to be a times negative 1 squared plus bx, b times negative 1, plus c. I don't know, write this part out, don't write it out, it's up to you. But let's clean it up. 2 equals, what's negative 1 squared? Negative 1 times negative 1 is positive 1 times a. It's 1a, or what I'm just going to say is a. B times negative 1?
Minus b.
Minus 1b, or minus b, and then plus c. Okay. When I number my equations, when I rewrite all three equations together, number them, this will be equation 1. Okay, what's the next ordered pair I'm using? If you can read it, sorry. 2, negative 4. So, y equals means I'm going to start with negative 4 equals. We're back to using standard form again, right? Ax squared. So a times 2 squared. It's a times x squared plus b times x, so plus b times 2 plus c. Clean it up again. 2 squared is 4. So 4 times a is 4a, plus b times 2 is 2b, plus c. That's what I call equation 2. And one last time. What am I doing this time? Yeah, we're plugging in our third ordered pair to get our third equation. So I'm plugging in 4, 2. Y equals, which means I'm going to say 2 equals. I just realized I forgot to write x, y above them. Not that you necessarily need that, but I like to have it there. Okay, ax squared. A times 4 squared. Plus bx. B times 4 plus c. So 2 equals, 4 squared is 16 times a, so 16a, plus b times 4, 4b, plus c. Okay, guys. That's kind of my preliminary work. And I don't know, are some of you to the point where you're not showing all this, you know, writing out all the pieces there? It's possible. Just be careful. So I'm going to rewrite these as equations 1, 2, and 3 and kind of flip them around here. So equation 1 is A minus B plus C equals 2. Equation 2 is 4A plus 2B plus C equals negative 4. And equation 3. (16A) plus 4B plus C equals 2. Okay, get those all copied over. Okay, we've got our 3 equations written. Pick what you're going to eliminate, right? That is assuming you want to talk elimination. But I definitely want to talk elimination on this one. Okay? So, most of the time, and in fact, if you want, every single time you can eliminate C on these. Because what are my C's always going to be? Plus C, plus C, plus C on all 3 of them. So, in this lesson, you could say every time, I'm going to eliminate C. Okay? So, just kind of a... Here's my reminder note. Okay, so we're going to eliminate C's. Now, yesterday, I took one of my equations and multiplied by negative 1, right? Since they're all plus C, plus C, plus C. Pick one equation, multiply it by negative 1, and take turns pairing that with the other 2. I would use equation 1 last time. Yesterday I used equation 3 because wasn't equation 3 A plus B plus C?
Yes.
And so it's really easy to just take 1 off of things. So in this case, my 1's are up on 1. And am I always going to have something that has 1A, 1B, and 1C? No. But I do. And so I would say multiply equation 1. If you'd rather just be in that frame of I'm always going to use equation 3, that's fine. Okay, it doesn't matter. So if I multiply this by negative 1, and then I'm going to take turns putting it with 2 and 3. How do you guys feel if I put 2 on top and 1 on bottom when I put them together? And again, I guess because I'm multiplying by negative 1, in my brain I am subtracting that 1. If you'd rather have 1 on top and 2 on bottom, that works. I'm just saying it doesn't really matter, I guess, okay? So if I take 2 and 1 and put them together. So 2 is 4A plus 2B plus C equals negative 4. What is 1 after I multiply it by negative 1?
Negative A plus B minus C, negative 2.
Good. Negative A plus B minus C equals negative 2. As always, or as I wanted, my C's are opposite signs, a plus and a minus. So we're going to add these equations together, right? 4A plus negative A.
3A.
3A. 2B plus B.
3.
So that's 2B plus 1B, which is 3B. C plus negative C. Cancels. Carry down your equal sign. Negative 4 plus negative 2. Negative 6. What am I going to call this?
Equation 4.
Okay. And again, if you are past the numbering phase and you're like, I got this, I don't need numbered, that's fine. But to me, I think I'm going to lose track of what equation's what if I don't number them. I guess it depends how organized I can keep my paper, right? Okay, so that's equation 4. How do we get equation 5? you pick two different equations, right? And so since we multiplied 1 by negative 1, that's why I'm going to use that one again, this time with 3. So 3, if you will, is 16a plus 4b plus c equals 2. Equation 1, but I want the version that was multiplied by negative 1, which negative a plus b minus c equals negative 2. My c's are opposites, yes? Plus c and a minus c, we're going to add them. 16a plus negative a. 15a. 4b plus 1b. 5b. C plus negative c.
Cancel.
Cancel. 2 plus negative 2.
0.
0. I'm going to call this equation 5. Okay. So, once you have equation 4 and equation 5, we put them together, right?
Solve for 1.
We're going to put them together and try and figure out what works best here. So, what if I go all the way to the left side of my page? This that'll give me, and I don't have to double back. So 4 is 3a plus 3b equals negative 6. 5 is 15a plus 5b equals 0. What would you like to eliminate?
A's.
A's? How can we eliminate A's?
Take
4
your
by negative.
take equation 4 and multiply by negative
Okay.
5.
If this is already 15a here, how do we make 3a become 15a? You multiply it by 5.
Opposite.
Because we're eliminating, I like a positive and a negative. So since this is positive, I'm going to make this one negative. So multiply equation 4 by negative 5, right? So if I multiply that top equation by negative 5, it becomes negative 15a minus 15b equals positive 30. Equation 5, I just carry over 15a plus 5b equals 0. My A's have opposite signs. I got negative 15 and positive 15, so we're going to add. Negative 15a plus 15a. Okay, that cancels. That's what we wanted. Negative 15b plus 5b. Negative 10b. Carry down your equal sign. 30 plus 0. 30. Okay, almost there, almost there.
Divide by negative.
If it's negative 10 times b, to solve for b, divide by negative 10. And so 30 divided by negative 10, b is negative 3. And this is a more enjoyable problem than the one we finished off with yesterday, right? Because that was fun fractions. But this one works out nicely. Am I done? Do I stop?
Oh, can you plug B back into
Yeah.
one of your equations for parking credit?
Remember, my goal is to find A, B, C.
I mean, you could stop at parking credit.
You can stop, but man, this is a lot of, you've done the brunt of the work here to not get full credit. Like, really? Why stop here? Okay, so take B and plug it into 4 or 5.
I plugged it into 4.
4? Okay. So if we plug it into 4, 3A plus 3 times b, which is negative 3, equals negative 6. 3a, 3 times negative 3 is negative 9. So 3a minus 9 equals negative 6. If it's 3a minus 9,
Yeah, 9 of those plays.
it's minus 9, we're going to add 9. 3a, negative 6 plus 9 is 3. It's 3a equals 3. Divide by 3, and a is 1. Now am I done?
No.
No.
Plug that in.
We've got a and b. Now my job is to find c. We go back to 1, 2, or 3 at this point.
I did 1.
Okay, 1 it is. So 1 says a, which is 1, minus b, so minus negative 3, plus c equals 2. And I went back to my original equation 1. So 1 minus negative 3. 4. 1 minus negative, right? Minus negative is plus. So if it's 4 plus c, I'm going to subtract 4. 2 minus 4? Negative 2. Now am I done?
No.
Good answer. Good answer. Why am I not done? Why am I not going to give you full credit right now?
Plug it in
Because
the
you have to
standard
plug it
form.
back into your standard.
Yeah. Last chapter, it was ordered triples, right? X, Y, Z. And I wanted that. Although I might still give you full credit last chapter if you didn't write it as an ordered triple. Depends. This time, though, it specifically asked for
Standard.
standard form, which, okay, I'm going to start with standard form is y equals,
AX squared plus BX plus C.
okay, y equals ax squared plus bx plus c. You're filling in ABCs. So, y equals
1x squared.
1x squared. Has anyone tried, does Math Excel let you put in a 1 for 1x squared?
It did for me.
So, and here's what I'll say. Paper and pencil, you can write 1x squared. I don't care. If Math Excel doesn't care, you're fine. Math Excel might care. They might not want the 1 there. Okay? So, key is you don't have to put the 1 there, but you can. So, 1x squared plus bx.
Minus 3.
So, minus 3x plus c
Minus 2.
minus 2. Realize I changed those pluses to minuses because those had negative b and negative c values. Okay. These are big, right?
Yeah.
I get it. How many problems did I give you in homework?
4.
4 again? So a lot like last chapter. Enough that I'm going to make you work, but I don't want you to spend, forever on this. Okay. So, your homework. If you haven't already started it, get working. If you started but not finished, get working. Is lesson 4.3 in Math Excel.